Hi, this is Sajjad, welcoming you to this video of Nuke Learning. In this video, I will review the time menu's time nodes. But to recall, I only go on the nodes that are being used mostly in productions. If you want to learn more about the nodes I don't go over, you can refer to the Foundry website. So from the top of the list, frame hold and frame range nodes are completely straightforward. Frame hold helps you pick one frame and use that frame at every frame of the input clip. Frame range node lets you set a frame range for a clip. This controls which frames are sent to be displayed in the viewer when the frame range source drop-down menu is set to input. You can use both of these nodes for 2D and 3D nodes. The next tool is Kronos. Kronos is a retimer designed to slow down or speed up footage. It works by calculating the motion in the sequence to generate motion vectors, which in turn enables you to generate an output image at any point in time throughout the sequence by interpolating along the direction of the motion. Kronos contains a number of controls to allow you to trade off render time versus accuracy of vectors. Let's get familiar with node options: FGVex and BGVex. If the motion in your input sequence has been estimated before, for example, using Vector Generator, you can supply one or more vector sequences to Kronos to save processing time. Most source and alternate source input if your source sequence is very noisy and interfere with the motion estimation. Matte, an optional matte of the foreground, which may improve the motion estimation by reducing the dragging of pixels that can occur between foreground and background objects. Source, the sequence to retime. Method sets the interpolation algorithm to use. Frame, the nearest original frame is displayed. Blend, a mix between two frames, is used for the in-between frame. Motion vector interpolation is used to calculate the in-between frame. Timing sets how to control the new timing of the clip. Output and input speed describes the retiming in terms of overall output duration. Frame describes the retiming in relative terms. Output speed, this control is only active if timing is set to output speed. Values below 1 slow down the clip, and vice versa. Input speed, this control is only active if timing is set to input speed. Frame, this control is active only if timing is set to frame. Motion sets the method of calculating motion estimation vectors. Local uses local block matching to estimate motion vectors. Regularized uses semi-global motion estimation to produce more consistent vectors between regions. Vector detail adjusts this to vary the density of the vector field. Strength, this control is only active if method is set to regularized. Sets the strength in matching pixels between frames. Smoothness, this control is only active if method is set to local. A high smoothness can miss lots of local detail, but is less likely to provide you with the odd spurious vector. Shutter samples sets the number of in-between images used to create an output image during the shutter time. Increase this value for smoother motion blur, but note that it takes much longer to render. Shutter time sets the equivalent shutter time of the retimed sequence. For example, a shutter time of 0.5 is equivalent to a 180-degree mechanical shutter, automatic shutter time. When enabled, Kronos automatically calculates the shutter time throughout the sequence. Note that this only produces motion blur when the retimed speed is greater than the original speed. Flicker compensation, when enabled, Kronos takes into account variations in luminance and overall flickering, which can cause problems with your output. And finally, Kronos is using the Foundry ocular technology for retiming. Now that we know the options, let me use this footage of two little girls playing. The test that I am going to show is based on slowing down the speed. Slowing down the speed of footage creates unwanted artifacts and unforeseen issues, while speeding up the footage don't have such issues. Connecting the Kronos to the footage is done by the source input. Connect Kronos to frame range, then activate it to see the results at its default settings, which decreases the speed of the footage and applies slow motion. As you can see, we have an artifact on screen left girl's face when the pillow is crossing from her face. The reason is the speed of the face is different than the speed of the pillows. This kind of artifact is happening almost on every shot in production, and you need to fix it. There is no specific rule for this node, and you need to play with the options to get the best results. I have explained how to use AI new technology to slow motion your shot in other videos. But for most of the shots, when slowing down, consider increasing the vector detail, decreasing strength, increasing the shutter samples, and activating automatic shutter time. Again, I am saying the settings from shot to shot differ, and you need to find a proper setting for your shot. I tested all the settings for my shot, and these settings give me the best results. Vector detail 1, strength 0.7, shutter samples 20, and activate automatic shutter time. Let me hit play by setting the play mode to bounce. As you can see, in frames 43, 44 and 45, I have a bit of problem on top, near the air conditioner. I can fix that with the help of Roto Paint node. Then, using the clone tool, start cloning these similar pixels to fix these frames. Also, I can draw Roto around problematic areas to have different operation on it, such as around this girl's face. I have a Roto here around the pillow for the whole shot, with the feather amount increased. Let me look through the frame range node. Let me disable it. And you can see my Roto around the pillow. Connect the matte input of the Kronos to it. Then, in Properties of Kronos, set matte to matte luminance or matte alpha. I can add blur node here. These settings might help you to fix the artifacts